Now we are seeing that covalent bond. A covalent bond is formed by equal sharing of electrons from the participating atoms, or both of participating atoms. So actually we are discussed with this covalent bond definition. So covalent bond is formed by equal sharing of electrons from the both participating atoms. The pairs of electrons participating in these types of bonding is called shared pair or bonding pair. So actually combining this bonding shared on these two atoms. The covalent bond are also termed as molecular bond. Covalent bond also molecular bond. The sharing of bond pairs will be ensure that the atoms achieve stability in their outer shell. Stability in their outer shell, which is similar to the atoms of the normal classes. So see that there the covalent bonding. A covalent bond formed when two or more electrons of atom in its outermost energy level are shared by other atoms. Example, chlorine molecule. So see that this chlorine. So see that example bonding between two atoms of same elements. And then another one is in this bonding a stable arrangement is achieved by sharing of electrons rather than transfer of electrons. It is a rather is a frequently used of the transfer of the electrons. Sometimes a covalent bond is also formed when two atoms of different metals or nonmetals shared one or more pair of electrons in their outermost energy level. So for example H2O, Cl2 different molecules and separate of water molecules. So actually H2O, so bonding between two different non-metals. So actually we are discussing properties of covalent solid. The covalent components are bad conductors of electricity. So this is a bad conductors of electricity. A covalent components are having low melting and boiling point, insoluble in water and soluble in organic solvents like benzene. See that the example and chlorine molecules and water molecules. The covalent bond occurs between non-metal elements when pairs of electrons are shared by atoms. So there is an example. We have discussed within ionic bond. Ionic bond, also called electrovalent bond, types of linkage formed from the electrostatic attraction between the oppositively charged ions in a chemical bond, such as a bond from when a valence outermost electrons of the one atoms are transferred permanently to another atoms. See this Na plus and Cl, Na plus and Cl minus. An ionic bonding is very attractive force existing between the positive ions and a negative ions when they are brought into close proximity or surrounding. So actually atoms are close proximity and surrounding. They are formed when the atoms or different elements lose or gain in their electrons in order to achieve stabilized outermost electronic configurations. So see that this Na plus and Cl minus. See that this, and then another one is properties of ionic solid. The ionic solids are rigid, unidirectional, and crystalline in nature. They are high melting point and boiling point. Ionic solids are good insulator of electricity in their solid state and good conductor of electricity in their molten state. The ionic solids are soluble in water, in slightly soluble in organic. The ionic bonding In sodium chloride, atoms of sodium denoted one of its electrons to one atoms of chlorine Cl. A chemical reactions and the resulting of positive ions Na plus and negative ions Cl minus from a stable ionic component sodium chloride common of table salt based this ionic bond. The hydrogen bond, the covalently bond atoms often produce an electric dipole configuration with the hydrogen atom as a positive end of the dipole. If bond arises as a result of electrostatic attraction between the atom, it is known as a hydrogen atom. The properties of hydrogen bond solids. Hydrogen bonds are directional, relatively strong bond. These solids have low melting point, no valence electrons, hence good insulator, soluble in both polar and non-polar solvents. They are transparent to light. For example, water molecules, ammonic molecules. The hydrogen bonds can be intermolecular, occurring between separate molecules. Another one is intramolecular, occurring among the part of the same molecules. So this is two types, intramolecular. Another one is intermolecular. The intermolecular is occurring between separate molecules. So this is one of the separate molecules. Another one is intramolecular, occurring among the part of the same molecules. Another one is depending upon the nature of donor and acceptor atom, which is the bond, the geometric and the environment. The hydrogen bond is a primarily electrostatic force of attraction between a hydrogen atom, which is covalently bound to more electronegative, or that is a covalent bonds to more electronegative atoms on group, and another electronegative atoms bearing and pairs of electron. So this is a hydrogen atoms bond acceptors. The hydrogen bonding interaction involving the hydrogen atom located between a pair of other atoms having a high affinity for electrons, such as a bond is weaker than the ionic bond or covalent bond but stronger than the van der Waals force. We are discussed with the metallic bonds. Metallic bonding is a type of chemical bonding that arises from the electrostatic attractive force between conducting electrons and positively charged metal ions. It may be described as the sharing of free electrons among a structure of positively charged ion. Metallic bond force that holds atoms together in a metallic substance. The atoms that the electrons leave behind become the positive ions, and the interaction between such ions and valence electrons gives rise to the cohesive or binding force that holds the metallic crystal. See that electrons are not bonded by the any particular atoms or free to move about in the solid. See, it has been observed that in a metal atoms, the electrons in the outermost energy level are loosely held by the nuclei. Thus a metal may be considered as a cluster of positive ions surrounded by a large number of free electrons, forming electron clouds. So many clouds also forming the positive ions in this sharing. Metallic bonding is a type of chemical bonding that arises from the electrostatic attractive force between conduction electrons and positively charged metal ions. So see that the properties of metallic solid: high thermal and electrical conductivity. This is a high thermal and electrical conductivity, low melting and boiling point temperature, high bright flexure. Metallic solids are decaying, and see that these properties of metallic solids. The metallic solids are ductileness, needle-like conductivity, the elasticity. So points. This is one of the properties of metallic solid. Advantages. And we are seeing this cubic crystal system. Simple cubic and so many areas. So if we see this dimension A, B, C, 3 directions. A simple cubic has a own lattice point, so it is a primitive cell. In a unit cell on the left, the atom at the corner are cut because only a portion in case of 1 by 8. So already seeing that for 8 years cell. So belonging to the cell, so cubic structures. So the rest of the atoms belong to the neighboring cells. So neighboring cells, you see that this neighboring cell A, B, C. The coordination number of the simple cubic 6 faces. See that this. We are seeing that only 1, 2, 3, we have 3 dimensional only. BCC is body center cubic. So BCC structures has 8 corner atoms and 1 body center atom. So see that this center of atoms. Each corner atom is shared by 8 units. So each atoms is shared with 8 unit cells. So already we are seeing this 8 unit cells. So the center of atom is not shared by this any of the unit cells. So see that this number of atoms per unit 8, 1 by 8 into 8 is equal to 1. 1 plus 1 is equal to 2. This is here 2 unit cells. So see that this ABC is center of this point is center point as a center atom. This is a body center cubic structure. This is also used in these structures of 8 unit cells. So this is not shared with this center atoms. So this is a main advantage of this BCC. And then is coordinate number. So corner atom, it is this is one of the FCC. This is face center cubic structure. Okay, this is a corner atom. In its own contains 4 faces, centered atoms. So see that this 4 faces. We are seeing 1, 2, and 3. And another one is see this atom structures 1, 2, 3, 4. So similarly in this plan just below, it has 4 more face center atoms. It is nearest neighbors. Therefore, it's no number of nearest neighbors. So 4 plus 4 plus 4. See, this is 4 plus 4 and 4 plus 4 and 4. So that is we are viewing for this 12 cells. So see that this cells. So many common metals. So crystals. So nowadays using for this lead, copper, and nickel. So this is one of the crystals which is structures. See the structures. And center of the cell is atom is face. Atoms, center of these atoms, and then is next is this is the closest nearest neighbor, so you're facing the area. And then 3 common unit cell in 3D. First is a simple cubic and body center cubic and face center cubic. So we have discussed with this. See that the simple cubic structures. So 8 cells, and then body center cubic is center of the atom. So surrounding this area is cells. And then see that this is a main one. This is a face center cubic. Face center is 8 cells with this center of atoms and 8. How many faces in this face center cubic? 1, 2, 3, 1, 2, 3, 4, 5, 6 faces.
So 6 phases means 6 atoms we are feeling with this phase center cubic crystal structures. This is a common unit cell in 3D, 3-dimensional structure. So nobody is using the 3D animation. So so many area will be we are weaving to this 3-dimensional video. So that of the part of this crystal structures we have dimensional 3 dimensions. So we are seeing this structures of this and major process of 3. And cubic crystals A, B, C, A is equal to B is equal to C. So see that the figure A, B, C is one of the cubic structures, and alpha, beta, gamma is equal to 90 degrees axis, and A, B, C is here axis, plane area, and 90 degrees A, B, C axis, and B is a plane, so 90 degrees. A simple cubic and body center cubic and face center cubic. This is around the crystal structures of the shapes. So element with this cubic structure. So FCC is here, aluminum, actinium, lead, nickels. So this is a germanium. So this is a FCC, face center cubic. VCC is a krypton, ferrous, rhodium, calcium. So this is a body center cubic. So this is also polymer. So this is a one of the cubic structures of this crystal structure. Thank you. So this is a beginner's level. So then